Start. So today's first speaker is Ben Frank. He's from the Island of TeX. So I'm sure that he will show us something about swimming, but also about Docker images and Docker containers. So the floor is yours, Ben.
Thanks. Good morning. So when we get slides here. On an island, we are quite fond of containers, not only for our own good. Today's talk is about living in containers, about TeX Live and ConTeXt in a Docker setting. And I'll try to explain what Docker is for those of you who don't know, and just have a look at our Docker images. Afterwards, we'll have a look at two use cases, so how to use these Docker images in a local setting and how to use them in the continuous integration setting. So this is by examples, and we will conclude it by mentioning some continuing challenges in the maintenance of the TeX Live Docker images. So what is Docker apart from a nice whale? Well, we do have some kind of file system that makes up a container. This file system is basically like your operating system on your hard disk, and you have an operating system layer and you have a software layer atop of that. And there could be more layers, but that's the basic principle. These layers are compressed into one file, and that makes up the Docker image. You can run it anywhere, so even on strange operating systems starting with a W. And so it's a portable way to execute software. And this is also what is quite of the intention, to run it anywhere, including the continuous integration settings of multiple hosters. We do provide, so the Island of TeX does provide two major branches of images, the context Lua MetaTeX image. We also have the context beta images, but they are quite out of date. So the Lua MetaTeX ones are the ones to take. And I only mentioned them first because the TeX Live ones are a bit more complicated. So we do provide the TeX Live releases from 2013 on, and they are split into two categories. We do have the historic images, which is basically TeX Live 2013 to TeX Live 2022. And we do have the latest images, so currently that's TeX Live 2023. The historic images receive monthly updates, and you might ask, okay, they are historic, what does change? Well, it's actually the operating system layer. The context images and the TeX Live images are both based off of Debian. So we do have a Debian system below that, and this is updated monthly. The latest images are updated weekly, including TeX Live updates and Debian updates. And we also provide a split for the latest images, so you can access all schemes that TeX Live provides. So you can download the image for scheme minimal up to scheme full. And we do not provide that split for the historic images, but we'll come to that later on. The defaults are David friendly. We do not include the documentation by default, but we also do not include the source tree by default. So if you need one of those two trees of TeX Live, you can request it by just adding a suffix to the Docker name. Okay, so let me just add one more thing. We try to make it quite self-contained. So each TeX Live image actually is shipping with the software that is required to run tools in there. So we ship with a Python interpreter for things like Pygments, which is required for Minted. We ship a JVM for Java tools like DataToolTK, TechOS Query, or Arara, and so on. So we try to make it self-contained so that you can simply run stuff in it. The two primary use cases we focus on when developing are the continuous integration setting and the local runs, which are also the two use cases which I will provide examples for today. Okay, so before coming to the use cases, let me just mention where you can find these images. We ship them at Docker Hub, which is like the most commonly used Docker registry out there, but we also provide them in the GitLab registry of the Island of TeX. Okay. After that short introduction, let me come to the first use case, which is about running these Docker images locally, so instead of a local installation of TeX Live. And I'll take the example of a small German non-profit math journal. This math journal has tech-based issues dating back to the 90s, and there are issues from 2022 that are already not compiling anymore because, well, some package maintainers do seem to like the idea of updating packages, and updates tend to break stuff if one is not careful and does not adjust things. So there is some major package starting with SI and ending with an X that has had a major change somewhere in 2021. The basic setup is about running locally, so this math journal has one machine that is used for the final compilation. And this one machine is the one that now should also be enabled to run older issues again, ideally by just using older TeX Live installations, and I'll come to the use of Docker in a moment. As a nota bene, they are currently establishing a compatibility policy so that in the future it's actually clear which TeX Live release to run on, but currently it is not. Well, the point here is we can use Docker on a local machine, and let's have a look at how that would work. So if you would run, or if you were to install a local TeX Live installation for the historic releases, you are probably, if you are not going the rsync route, you are going to pull the ISO image of the year and install with the install.tl installer from this ISO image. And in contrast to that, you can actually just Docker pull a Docker image of the historic release. And in our naming scheme, it's quite simple. It's TL, then the year you want to pull, and historic. As we don't provide schemes for the historic images, you can't make any error here. The only thing, if you need the documentation tree, you would add -doc after that, or -source if you need the source tree. So quite simple. This is the pulling part. You can also remove it quite easily. This would prune or remove all Docker images from your system, so use with care. You can do it for singular images too. So installing and removing is quite easy, and you don't have to wait much except for the download time. That's a plus. And the running part is actually also quite interesting because you don't have to do any path fiddling. So if you install from the ISO image, run install.tl, you have the installation of TeX Live on your machine. But it's not, you do have to take care if you have multiple TeX Live installations, which is actually run at the moment. And this is something which you basically cannot do wrong with the Docker images because you always specify the image you want to run in. In this case, we would run in a 2018 image. So to dissect this call a bit, we have Docker run. We want to do it interactively so that we see the output of the command we run. The command is the last part. It's the rara-v issue.tech part. Verbosity doesn't matter really much. This part is about just mounting the current working directory into the Docker image, and well, that's quite needed, so you have actually the Docker, the document you want to compile available for the image to compile, and that's about it. So now the obvious question is, why should we use Docker here? And one thing to consider is that, yes, I mentioned it's all on one machine for this journal, but there are contributors, and this is a stakeholder that is often forgotten. So it's also quite nice if the contributors already can hand in articles that will compile. And it's made easier if they use the same TeX Live as everyone else. And that's made easier by them having to do basically the same single line commands. So it's quite easy to communicate how anyone could have the same setup and make sure something compiles. Furthermore, you can describe all of that on one A4 page, which is not that easy to do if you want to describe a TeX Live installation per se, because this is platform independent. So it's regardless of whether you use Windows, Linux, Mac, you can use these Docker commands, which on, so after you install Docker, of course, which you cannot do in with usual TeX Live installation. So there are quite a few advantages in terms of communication and in terms of just platform compatibility. You can do all of that manually, so it's just an alternative way. The second example is actually easier to argue about, and this is about the continuous integration setting. So continuous integration is basically the process of pushing some document mostly to a version control hoster and then triggering some workflow like compiling a TeX document. And we will look at an example which is about compiling the minutes of student representatives meetings. At the example of the computer science students from the University of Jena, you can find their minutes on their website. There's a menu point, Fachschaftsrat, Protokolle, that you can look at them if you are interested. They do have weekly meetings. They record their minutes of the meetings, and well, it's completely CI-based, so everything they record, they just push into a Git repository. This Git repository compiles the documents and pushes them to their website. They do use ConTeXt initially because of limited CI resources. I will come to that point in a minute, but yes, it's just stuck. Okay, this is the basic idea. We have some document, we push it to a Git hoster, it runs a workflow, and yeah. Why is it native to use Docker images here? Because most Git hosters actually want you to use some Docker image because you do not have control over the runner that executes the workflow, and Docker is mostly used for a separation of concerns so that you do not interfere with some other user. Okay, so on GitLab it looks like this. If you want some kind of workflow, it's quite easy to understand. You specify the Docker image. In this case, because it's ConTeXt, we use the LMTX image. Then you specify the command that is to be run. In this case, we just find all TeX files and run ConTeXt on it. And the artifacts part is about which files are we interested in after compilation, so after the script part finished. And in this case, we are interested in all the PDF files that have been generated. Okay, so there is one line that is actually doing something and one line that doesn't quite fit our needs, and this is the one. So if you imagine the use case of compiling minutes, you probably know that you won't touch minutes of a year ago anymore. So recompiling all minutes again and again is quite a waste of time and quite a waste of CI resources. So what you want to do is you want to do some magic, like compile only what is needed, and you can do that with simple bash scripts. And the reason why I will go into this will be clear after a few slides, so please stay with me. Do not be scared of this bash code, let's call it that. The basic idea is to just fetch the last commit that was made to the repository where the GitLab pipeline actually ran. I didn't include the curl call here, but it's quite easy to find in the documentation. So get the last commit where the pipeline ran, then look for the changed files since the last compilation, and that's actually only a git diff tree call. And afterwards, well, this is a quite important part. Check whether anything has changed which influences all documents. This is usually the part you forget when you introduce caching into your workflows. So this is something to watch out for. In this case, we just check if one of the environment files, which is the context equivalent of user packages, user styles, has changed. And if it has changed, well, all documents have changed and we should recompile everything. And that's the case where we do the same find we did before and just run ConTeXt. Okay, so that was the part which is actually doing pretty much the same as the one line before. But the interesting part is about this one, where we do not compile everything, but where we do take the simpler route of simply compiling what has changed. So usually you would have an if condition that checks on the compile all variable, but for presentation purposes, this is split up. So this is actually everything you need for a basic workflow of compiling only what is needed. And why I do mention it is the following. So the repository we are talking about has about 200 context files and about 100 LaTeX files. And if you look at how long it would take to do a full run, so translate every context document and translate every LaTeX document, it's about the same time, although the number of files is quite different. So one important part to note about the LaTeX files is they tried really hard to make them to compile as long as possible. So they use Arara for extra long startup times. They use Lua LaTeX with custom fonts. They use PGF and tcolorbox for extra file I/O. So it's basically the try-hard version of make it compile long, but also the try-hard version of make it look nice. Good. So we do have an explanation why it could take long. But the interesting part is about the incremental build time, which is basically you have a newly recorded session, you push the minutes to the repository, and it's basically one document that is to be compiled. And for one document, you see quite a difference. Now, some of you may guess what the culprit could be. But let us say, if you use that many packages like tcolorbox, etc., you pull the full TeX Live. So the full TeX Live scheme is about 2 gigabytes without documentation and source tree. And the ConTeXt Lua MetaTeX standalone distribution is about 250 megabytes. So it's about 1/10 of the size. So for this part, we do have about 30 seconds of only pulling the context image and about 2 minutes of pulling the full TeX Live scheme and extracting the image, etc. So it's quite like, yeah, a lot of difference is only in pulling the image. And well, the compilation difference is not that much, so I won't go into that. And now the point is not for you to, if you want to use efficient continuous integration, use context, well, you can, but I want to make 2 points with this slide. Point number 1 is, be careful what you pull, because this is this has an impact on your runtime. If you want to pull a full TeX Live, do so in the full awareness that this will be 2 gigabytes. If you don't need a full TeX Live, rather pull a smaller scheme. Doesn't work with the historic images at the moment, but with the latest images, it's a good idea to pull only what is needed. And on the other hand, it is quite important to have an awareness whether you need to recompile everything in each run. So if you do continuous integration, the basic idea was that you do a continuously small batches and compile and compile and compile so that you get quick feedback. And quick feedback is achieved in the most efficient way by doing only what is needed, and therefore try to have an awareness where you could cache your output files. So this was a quick run-through to the 2 primary use cases we focus on with some examples. So locally running TeX Live with Docker and running TeX Live with Docker in a continuous integration setting. So let's have a look at the challenges we face while maintaining the images. And at this point, we do have to thank Mariah and Vit for providing us with custom GitLab runners at the moment, because beforehand it was very hard to build the images reliably. Now we do have a bit, let's call it improved robustness, but at the point where we do have manual intervention each week, which is not what we aim for. So we would like to automate it even more. So this is one point where we would like to improve on. Then I already mentioned that currently only the latest images are split by schemes. So we would like to do that for the historic images as well. It's a bit non-trivial, but we will come there eventually. Okay, we would also like to automate building new historic images, because currently when TeX Live 2024 will be released, the latest image will have the correct tag. It will be TeX Live 2024, but the historic image for TeX Live 2023 will not be built automatically. And we would like to produce more architectures. The most important one, ARM actually. So ARM is, for instance, Raspberry Pis or smartphones. It would be interesting to have a native architecture version for them. So this is currently more low priority, but because we have custom runners now, we can try in that regard. And we would like to improve the layer friendliness. So there are differing needs for how you would want to compose Docker layers, especially with updating. So with the weekly updates, if you have your image locally, you do want to pull only what has changed. So you don't want to pull 2 gigabytes each time. But in a continuous integration setting, you do want to have fewer layers because the recombination phase can be more compute intensive than you want it to be. There are other aspects to that, but this is clearly something that needs design work and trying things out. And at that point, we invite everyone to join us and to try to present your use cases, come up with ideas, or even code something which improves the images. We are currently at over 1 million pulls for the Docker TeX Live images, so it's not that this is quite unimportant, but the usage grows. Okay, and that is the point where I can only invite you to the island and not only to this sub-project. So visas for the island are free and easy to get. You can find us on GitLab and you can find us in the Matrix channels. And now to end with the famous last words of Paulo, cheerio, and this is the time for your questions.
Thanks, Ben. And Ben asked me for an extended session for questions, so we have like 8 minutes.
Well, thank you very much. Do you have images for other processors than Intel?
That's the point of the multi-architecture images we So we currently only build for x86 64, so 64-bit x86 architecture. We do want to build for other architectures, but it's currently not set up. But as we have custom runners, we can use Docker build X to build other architectures. So if we have some interest and maybe some person to implement it, it will be there.
Thank you.
Any more questions?
I suppose following on from that, why do you need different images? Because TeX Live doesn't need, it's only the binaries and they're really small. Why don't you just include the different platform binaries and then?
Because we also ship the operating system. So Docker images are more than just the software layer. We also have the operating system layer below, and if that is fully emulated by Docker, it's not as efficient as running native software. So the Debian we ship is x86, and yeah, Docker is able to emulate it up to some point, but we would like to have images that fully run on the architecture.
Okay, more questions? David?
Yeah, so you were showing that the image pulls can be a considerable time. So if it's in a CI situation, do you have a feeling for whether it's better to, obviously most CI systems let you cache something within the CI system, so would you pull the Docker image each time you commit, or would you sort of set up a pre-cached in the CI system that had the Docker image pulled, or does it not make any difference in the end?
Well, it does make a huge difference if we have a cache of the CI images. The problem is that usually when you do run on a shared hoster like GitHub or GitLab, the image caches are cleared. So the shared runners, there are a plethora of shared runners, and if you are happy enough to land on one which just has pulled the same image a few moments ago, you will reuse that image. So the time would be far less here. But you cannot influence it too well in the shared runner scenario. If you have your own runners, yes, definitely go ahead and cache these images, because you don't have to pull 2 gigabytes each time, it will be faster. So Marai and I even discussed a few hours yesterday that it would be great if we had some kind of tag-oriented CI where these images were pre-cached. It would be great because it would reduce running time significantly.
Thanks. More questions or comments?
To follow up on Joseph's question, there is actually the possibility to use multi-arch in Debian. So you can pull binaries for different architecture within the same Debian system, which is actually not so hard inside a Docker setting because you don't need a kernel. And since you don't need a kernel, you only need to duplicate all the libraries. And in TeX Live, you can install binaries for any architecture. So you can actually have a single TeX Live tree that has binaries for both ARM64 and x86.
Let me answer with a remark that is half true. We try to optimize our images for size. This would be a size increase, which is not significant these days. So for the context images, it would be significant, but for the TeX Live images, it would not be, because of I think, I haven't tested it, we would get from 2.1 gigabytes at the moment probably to 2.5, 2.6 gigabytes. But we try hard to have them as small as possible. So we actually want to try really building them for one architecture only and providing them separately, because Docker allows to provide images with the same name and different architectures separately, and that would be the clean solution which we have in mind. So it would be a stopgap to do that, right? And maybe we even would accept a merge request that shows the possibility of this, and maybe also that it maybe is not that big of a size increase, but currently we do think for a more clear design.
Okay, thank you. More questions? We still have about 2 minutes.
The other thing is just a general comment for users, actually, to not use latest, not use the TeX Live :latest image, because that's really cache unfriendly. So, for example, I was always using these TeX Live images in a local CI on a self-hosted GitLab runner, and there, if I just pin the image version to a certain date, then I don't actually ever have to pull the image again. It just sits there and it can be reused instantly, which actually saves quite a lot on this startup time of the runner.
Yeah, so this is the point about the layer friendliness here. Currently, if you pull latest again, you will throw away 2 gigabytes of a fine image, and you will pull 2 gigabytes of a new image because everything is in one package. So this is the point where we would like to improve on with only pulling updates or something, but it's more for the, that's the part where quite a bit of design work would be interesting. But yes, caching the image and maybe running TL Manager update once in a while is more efficient than pulling it again and again if you have the possibility.
Cool. We have like 1 minute left, so maybe a quick comment. Okay.
Do you have any statistics how much people are using the historic images?
I have not checked it. So Docker Hub has on the page where the images are shown, it has download statistics where you can only show or where you get the pulls for the full repository. So we have 1 million plus downloads for the latest and historic images combined, but we do not know the specific statistics.
Okay, cool. Thank you. So thanks, Ben, again, for the nice talk and the nice discussion.